Hi everyone, today I will teach how to solve the lecture for moment 3D in our static and dynamics. And for this video, I will explain how to do the question 7. And first of all, to solve the question in moment 3D, we need to know the cross product formula first. And the formula is it's a diagram below, as you can read this. And then for question 7, the question given two different forces, which is F1 and another one is F2. And the information given AO equals to BO and equals to 2 meter. That means the AO here and OB here is equal to 2 meter. And then the question asks us to determine the moment generated by these two forces on our point A. That means we will find our moment produced by these two on our point A, and I will use the formula here. Moment at point A is equal to moment produced by F1 at point A plus moment produced by F2 at point A. So to use this formula, we have to find our moment F1A plus and moment F2A. So we do it one by one. For moment F1A, the formula given by is M equals to RF. The reason why I use the RAO here is because the R is measured from our point, which we like to find moment at to the point, the force. So for F1, we have to look for the RAO. So for RAO, the distance is 2m, and for RAO, the RAO moves along the y-axis. And so our 2m is our component Z. And then we have to know about the component. We have three components. One is I, and the second one is J, and the third one is K. Component I is for our x-axis, and component J is for our y-axis, and component Z is for our and the component K is for our z-axis as well. So for RAO, if we want to move from point A to point O, our J component is 2, and whereas our component I and K is 0 is because the RAO doesn't involve any x-axis and z-axis, as you can see in the diagram. So our RAO is equals to 0i plus 2j plus 0k. And then after we find our RAO, so we have to calculate our F1 now. So for F1, the information given is F1 equals to 300 Newton, and the information given is theta x is equal to 60 degree and theta y is equal to 70 degree. So by using these two information, we can get the theta 1x it's theta 1z by using this formula. I substitute the information here, we will get the information like this, and our theta z will equals to 37.29 degree, and another one is 142.71 degree. Yes. The reason why we get two different values for our theta z is because you can see more clearly with this diagram. So you can see the F1 is here, our z-axis is here, and our y-axis is here. So our theta here is referred to our theta z. So the theta z means that the theta from the force F1 to the z-axis. So we will have two angles here. The smaller angle will refer to our 37.29 degree, and the bigger angle will refer to our 142.71 degree. So for this video, I will use the value of 37.29 degrees. So by using the formula to find the f, and then I will get this equation. And the reason why you can see the negative, I put the negative sign here is because instead of putting the plus sign in the formula, is because that when I use the 37.29 degrees, which is the smallest degree, so the small degree is between the f1 and the negative z-axis, so I will need to put a negative sign at here. And if you use the 142.71 degree and your answer here, you will need to put the original plus instead of negative sign here. So after calculating, we will have to calculate our moment produced by F1 at point A. And then by substituting the value inside, and here we need to use the cross product as I show to you all at the first of the video. So my cross product, I will get the equation here, and the final answer I will get here is negative 447.3475 I plus 0j minus 300k Newton meter. Newton meter is the unit for our moment. So after finding our moment F1A, now we have to find our moment F2A. So for moment F2A, by using the same formula, F equal to R cross product with F. So in this case, we are using R and B. It's because we need to measure the length between the A and point B. From A to B, because point B is the one of the point of our F2. So since the B allocated here, our A will pass through the O and go to the B. And then for 3D moment, we have to use the IJK component for our R instead of the 2M here. So if you look from the top, you will get the image here. So by using the Pythagorean, is the trigonometric identity, we will get the two length here. So the 2 cos 45 degrees is move along the x. So this one is our component I, and for the 2 sine 45 degree, M is for our component K, because it's moved along the z-axis. And then if we move from our A to B, so means that we move from A to O and O to B. So here we have to move from O to B. From O to B, our component I is positive, and for our component K is positive also. And then actually the 2 cos 45 degree is equal to 2 sine 45 degree, which is equal to sub 2. And then I will get the R and B, sub 2I plus 2J plus sub 2K. And the reason why I put the plus here and here is as I explained just now. So after we get our R and B, now we have to find our F2. F2 is given by 500 Newton, and here they given the information 1.6, 2.4 and 2.8 meter for the length of the force F2. So if they given the information like this, we have to find dx, dy, dz. So we will see the 2.4 m first. The reason why 2.4 m is our dx is because the 2.4 m is parallel to our x-axis, and then the F2 is moved to the right. So our dx is plus And for 1.6 is dy is because it is parallel to our y-axis. So we can see that clearly that the f2 is moved downward for the y-axis. So our dy will have a negative sign here. And for the 2.xm is for our parallel to z-axis, so it is our dz. And then we can look the f2 move towards the positive z-axis, so our dz also positive. And then we have to use the Pythagorean theorem again to find our d. And then our d is equal to 2 third 101 divided by 5m. And then by using the formula, we will get our f2 here equals to the answer here. And then after we get our f2, we can calculate our moment produced by f2 at point A. And by substituting the value inside, we will get the equation here. And then we have to do again for the cross product, and we will get the equation here, and the final answer is here. And then since the question is asked for moment produced at A, so and then this is the answer we find just now, and for moment f2A also. And then we were using the formula earliest to find our total moment produced by the two forces at point A. So we have to plus the two moments together. So by substituting the value inside, we get the equation here. And for the plus for component ijk, the I component plus with I component, and j component is plus with j component, and also for the k component. So we will get the equation here, and then our final answer is 500.7122 I minus 70.3597 J negative 1178.5561 K Newton meter. So this is our final answer for our question 7. So that's all. Thank you.